Hello viewers, in today's session we are going to discuss another important problem from continuity of functions involving signum function and mod function. So here we are going to discuss this problem where we have to discuss the continuity of this function f of x, which is a combination of signum function and the mod function. So here we have the function signum of x plus mod of x, and we have to see whether this function is continuous at x is equal to 0 or not, right? So let us utilize the definition of mod function and the definition of signum function to prove whether this function is continuous or discontinuous at x is equal to 0. So let us start. So let us first quickly revisit the definition of signum function and mod function. Now see, mod of x is defined like this. Mod of x is positive x whenever x is greater than 0. That is for all positive numbers. And here mod of x is equal to 0 whenever x is equal to 0. And mod of x is negative x whenever the real number x is less than 0, right? And from here we can easily claim that the domain of this function is the set of all real numbers. And the signum function is defined like this, that is signum of x is positive 1 for x greater than 0. So whenever this x is a positive quantity, then signum of x is positive 1, and signum of x is 0 for x is equal to 0, and signum of x is negative 1 whenever x is a negative quantity, right? So these two definitions are going to be very important while proving the continuity and discontinuity of this function at x is equal to 0. Now let us take the real number line, and here we have x is equal to 0. So when we approach towards x is equal to 0 from the right of x is equal to 0, then we get the right hand limit. And when we approach towards x is equal to 0 from the left of x is equal to 0, then we get the left hand limit, right? And towards the left and towards the right, we'll take 2 points. Here we have this point, that is 0 minus h, and this point that is 0 plus h, so that we have this interval that is 0 minus h and 0 plus h, right? So when we calculate the right hand limit, then we take x is equal to 0 plus h, and remember this h is a positive quantity and it is infinitesimally very small, and it lies between 0 and 1. And when we calculate the left hand limit, then we take x is equal to 0 minus h, right? So let us calculate the right hand limit and the left hand limit separately. And from the definition of continuity of functions, we know that a function y is equal to f of x, which is defined in some domain, say d. And if we have a point, say x is equal to a, and if this function is to be continuous at x is equal to a, then the right hand limit should exist and it should be finite. Similarly, the left hand limit should exist and it should be finite, and the value of the function at this point should also exist and it should be finite. And moreover, these three quantities must coincide to a common point, that is these three quantities must have a common value, or these three quantities must be equal to each other. So now the notation for the Right hand limit is given by limit x tends to 0. Here our point of consideration is 0, and we write x tends to 0, and here we put a positive sign, and here we have f of x. So we can now write this limit in terms of h by taking x is equal to 0 plus h, that is simply equal to h. And when x tends to 0, from the right of x is equal to 0, then h tends to 0, right? So we can now write limit h tends to 0, and here we have f of simply h, because x is 0 plus h, that is equal to h. So now we can write limit h tends to 0. F of h can be obtained from the function by replacing this x by h. So we have signum of h plus mod of h, right? So we have now limit h tends to 0, and this is signum of h plus mod of h can be written as simply h, because from this definition, because mod of h is equal to h, and h is a positive quantity. So now we can write limit h tends to 0, and here we have signum of 2h, right? Now see here, we cannot directly substitute h is equal to 0. And what we will do, see, h is a positive quantity, so 2h must also be a positive quantity, because when h is a positive quantity and 2 is also a positive quantity, then the product of 2 and h should be a positive quantity. So here we have a positive quantity. So whenever we have x greater than 0, that is whenever x is positive, that is this quantity is positive, then signum of positive quantity takes the value plus 1. So here this limit is now equal to limit h tends to 0, and we have plus 1, right? For signum of 2 plus h, that is signum of 2 times of h is equal to a positive 1. So here we have positive 1, and omitting this limit notation because this is independent of h, so we have plus 1. So the right hand limit is equal to a positive 1. Now let us calculate the left hand limits. The notation for left hand limit is limit x tends to 0. Here we put a negative sign, and we have f of x. So when we move towards x is equal to 0 from the left of x is equal to 0, then we take x is equal to 0 minus h, and h is a positive quantity, and this is equal to 0 minus h is equal to negative h. So we can now write when x tends to 0, then h tends to 0. So we have now limit h tends to 0, and we have f of negative of h. So we can now write limit h tends to 0. F of minus h can be obtained by replacing x by a negative h. So we can now write a signum of negative h plus a mod of negative h, right? So we have now limit h tends to 0, and this is signum of minus h plus h, because a mod of negative h is equal to a positive h, right? By definition of mod function, because see, when we have x less than 0, right, then mod of x is negative of x. And here when we have minus h less than 0, then a mod of negative h is given by negative of negative h, that is positive h. So we have here positive h. So this limit is now limit h tends to 0, signum of 0, because this h and this negative h get cancelled. So now the value of signum of 0 is equal to 0, because when x is equal to 0, then signum of 0 is equal to 0. So we have now limit h tends to 0. Here we have 0, that is equal to 0. So we have now the left hand limit equal to 0. Now let us calculate the value of f of 0, that is the value of the function at this point x is equal to 0. So this is signum of 0 plus mod of 0, that is signum of 0 plus 0, mod of 0 is 0, and here we have signum of 0, and signum of 0 is equal to a 0. So here we have 0, right? So viewers, we have seen from this discussion that the right hand limit is positive 1, the left hand limit is equal to 0, and f of 0 is equal to 0, right? And we can see that the right hand limit and the left hand limit are not equal to each other. So here, although the right hand limit and the left hand limit, they exist and they are finite, but they are not equal to each other. That is, one is not equal to 0. So we can claim that the limit of the function, that is f of x at x is equal to 0, it does not exist, right? Because for the existence of the limit of a function at a given point, the right hand limit and the left hand limit must be equal to each other, right? So here the limit doesn't exist, so we can easily conclude that the function is not a continuous function at this point, that is x is equal to 0.